Gravitational constant. You see, the choice of capital letter for representing it itself reveals the very essence of capital G. You might say as an honor we use capital letter G, but for small g, that's acceleration due to gravity, it's subject to change depending on the height, depending on the depth, depending on the location of point concerned on the entire earth. So here we'll first consider above and below the surface of the earth how g changes. If we consider the point above the surface of the earth, its center, radius of earth is represented by letter RE, and just suppose this distance is h. So from here O to this very point, you might say the distance, entire distance is RE plus h. You see, if you consider this point, then at this very point, the entire earth, the whole volume, the whole bulk of this earth is affecting this point. It is applying the gravitational force on the object at P. So we use the relation G equal to G ME upon RE square, and for this very point, this would be GME upon RE plus H whole square. If you write this RE plus H as S, you'll find the relation G dash proportional to 1 upon X square. The relation will be this way. Moreover, if you take the ratio of the two, you'll find G dash upon G. This is equal to RE upon RE plus H whole square. That could be on the basis of binomial theorem. You'll approximately get the result G dash upon G, this ratio equal to 1 minus 2H upon RE. And if you take this one, G dash minus G, that's going to be equal to G 1 minus 2H upon RE, or delta G dash equal to this thing. And if you see G dash minus G, you write this thing, it's going to be minus 2H upon RE. Delta G minus 2H upon RE into G. If you approximate, then only you are going to get this, because binomial theorem is applicable only when the entire power is less than 1 or the denominator, the whole fraction is less than 1. So there one approximation is applied, H is very small, this thing, only then this relation is going to be applied. Finally you get delta G upon G, it is minus 2H upon RE. This relation is applicable for all the points above the surface. Similarly, now I would proceed by considering the points below the surface of the earth. Other way you could say under the surface of the earth. See, I'll consider the point over here. This is at a depth D, the whole radius is R, E. Then the distance from center, that of the point, is going to be RE minus D. This is going to be D. This is RE minus D. Now, we'll use this relation for G, 4 by 3 pi G D R E. D stands for density. Here we have used rho in place of D, all the same. D stands for density, whereas here rho stands for density. But when you consider the point inside, the total volume of the earth is not effective at this point lying inside the earth. That's why we have chosen this formula in which density is involved, not the mass. Density throughout the earth shall be considered almost constant, whereas total mass of the big sphere, another, of the smaller sphere lying within this point P, that will be smaller sphere having less mass. So we haven't preferred the formula using mass. We are taking this formula, and for points inside it's going to be Re minus H. So first thing, Re minus H, this is D, I have noted here D. So G dash is proportional to Re minus D. If you choose X for this, then this will again be a linear relation, whereas there it was curve. And moreover, if you just take the ratio G dash upon G, it's going to be Re minus H upon Re. That becomes 1 minus H upon Re. And if you take the difference, you will find finally delta G upon G equal to minus H, or whatever you choose, minus D. So the two relations you are having, here it is the depth H and here it is the height H. Above H and below H. Below it's a linear relation, above it's along the curve. One thing goes common here, you see above and below the surface G decreases. Either way you will find the decrease in value of G. But while going upward it decreases faster, and while going downward it decreases smaller way. And the ratio in the two changes will be 2:1. One more difference is there. Above it's a relation that's along a curve, and below the surface it's a relation that's a linear exactly along a straight line.